Well, thanks very much for having me. And I think this is more of a starting point. Uh, I think there's a lot of work that we can do in this area. And so, in some ways, we're trying to lay a kind of a foundation for how to do this kind of research. And then there are some issues that we should definitely talk about how to connect this kind of research to other ways of measuring well-being in a way that's useful. But I think that's more for the discussion period and for future projects. Okay, so I want to start with a familiar question. On a scale from 0 to 10, how happy are you at this moment? So, not a difficult question to come up with a number. Where it comes from is maybe a little bit trickier, but you probably have some idea what made you say a particular number, and that number may be different than it was a couple hours ago, and maybe different again in another hour. And if we just picked some things that are probably relevant, things like how we slept last night, what we had for lunch, what we spent our afternoon doing, those are probably all going to in some way influence this number. And my big question is, if I know exactly what you've recently experienced, can I predict exactly what you will say? So I think a natural place, at least coming from a neuroscience background, a natural place to start on this is value-based decision making, because I think most of us think that the choices we make and the actions we take are in some way relevant to how we feel and to our emotions. And this is an enormous field within psychology and neuroscience, and so I think it's maybe a helpful or a useful starting point for a better understanding of how we feel from a better understanding of how we feel from minute to minute. So if we just take a scenario like getting offered two different drinks, one a glass of orange juice and one some strange vegetable drink, we can assign values to those different options and we can make a choice between them based in at least in part on those values. And so there we have our choice. And then when we drink the drink, uh, we can evaluate how that experience was and in some ways take into account what we were expecting. So if it's exactly like we expected, then we don't really need to change our beliefs about how good this item is. But if it actually is better than we expected, then we could use that information to learn. And actually, in this situation, let's say it's this vegetable drink is better than expected. So if we're offered it again in the future, we would be more likely than we were to choose it again. So this all makes a lot of sense. It makes sense that over time you learn from your experiences, and that would inform the values that you hold for different kinds of stimuli and actions in the world, and make better and better choices over time. Now, one thing that's obviously I haven't mentioned yet, but obviously is where we're going, given the interests of that I have and that this group has, is emotions and feelings. So these very well understood psychological concepts, and actually at the neurobiological level, they're also well understood. There's no link really in a lot of this research to emotions and feelings. And so when I started this research, what I was really interested in is whether the variables in these value-based decision making and learning models could be used to explain happiness, explain feelings. So we've done this both in the lab and using smartphones. I'm just going to show you what it looks like in the smartphone app. Actually, we have a second smartphone app that we launched earlier this year called the Happiness Project. It has 4 different games based on our research across a bunch of different domains. But it has also a similar game to one in our earlier app, which is focused on risk taking, because risk taking is actually quite simple and quite easy to generate predictable behavior. And so I think it provides a natural starting point for a better understanding of the relationship between reward and happiness. And so this is what our basic game looks like, which anyone around the world anyone can download this app and play it. You can play it right now if you feel like it. And so in every trial, you're making choices between safe and risky options. And when you take the risky option, you spin a spinner. Here, losing 54 points. Another loss. Okay, so not surprising, this player is not very happy about how things are going, given what's just happened. All right, so if you're kind of playing along in your head, hopefully it seems intuitive that at this moment, this player, or maybe you, if you were playing it, would be happier than you were 30 seconds before and would mark something higher on this scale. And so an obvious hypothesis is that it's just your score that determines how you feel. It's pretty salient, and you don't have to remember anything, and it's on the screen. It says you have 600 points just before you make this rating. And so it could be that the happiness you report is just how well you're doing in the game, and the score is a measure of that, a very simple measure of that. And this is lab data. This is data collected at UCL with the master's student Nicolina Scandelli, and also with Ray Dolan and Peter Dayan. And this is 3 example participants playing the game, basically almost identical game, but for real money, and playing for an hour. And each of them starts with 20 pounds, and each of these participants ends up with over 30 pounds. Actually, I think the second one ends up with almost 40 pounds. So pretty lucrative for this 1 hour long experiment. And so doubling your money seems like exactly the kind of thing over an hour long experiment that should increase your happiness. So that is the hypothesis. Does happiness increase along with their wealth over this short time scale? And that is not what happened. So this is happiness ratings for these 3 participants, and this is pretty typical. It's not as if they always rate the same thing all the time. They move their rating around quite a bit, but there isn't a close relationship between how they report feeling and how well they're doing in the task, at least as determined by their current level of wealth. Okay, so if it's not how much money they're making, or how much money they have, or how many points they have, that's determining how they feel from minute to minute, what is it? If we think from a psychological and neurological perspective about what the brain is representing in an experiment like this, one kind of foundational concept in neuroscience is this idea of reward prediction errors. The difference between what you got and what you expected to get, which I kind of hinted at before. You shouldn't have to change your beliefs if you got exactly what you expected, but if you got more than you expected, you should increase your value estimates. If you got less than you expected, you should decrease your value estimates. And this is something that the neurotransmitter dopamine is thought to represent, and that you can measure. These are some studies that I did some number of years ago now, where we measure reward prediction error signals in the human brain. They're quite easy to measure. They're very robust, and across a large variety of environments, you can measure these prediction error signals that are related to the neurotransmitter dopamine. So based on this intuition we had from our understanding of what the brain is doing in an experiment like this, we proposed this model. So we asked whether the happiness that you feel depends on the certain rewards that you choose, the expected values of the gambles you've chosen, and the reward prediction errors that resulted from those expectations. And the only other details to think about in this equation, so obviously you're summing up over all of your experience. The gamma parameter is a decay factor, forgetting factor. So if that's 1, you never forget anything. If it's 0, you only remember the most recent event affects your happiness, and everything in between. And then the W0 is a kind of a set point around which your happiness could oscillate. All right, so this is our model inspired by the understanding of the neurobiology of reward. And this is the data that we're trying to account for. And this is how we do. So in red is the model fits, the 1 step ahead predictions for these participants. And it does a much better job than just knowing how much money you have. You really need to know this history of recent events, recent choices, if you want to predict what people are going to say in this experiment. So, okay, what do these parameters mean? Well, these are the average parameters across the first 200 players to download the smartphone app. We see they're all significantly positive. One thing that we find consistently is the reward prediction error weight is significantly higher than the expectation weight, which actually is kind of important, because if they're identical, those influences cancel out, because expectations have a positive influence on happiness, but as part of a reward prediction error, they have a negative influence on happiness. Is it the first 200 players? Here's the next 200. Here's the next 200. This is extremely consistent result. Every subgroup of this sample, we have the same result. We have the same result in the lab. And we can even do this for just 1 rating for each person from the smartphone app. This is 18,420 participants, 1 rating per person. It's the first rating after the first 30 seconds of playing the game. Same pattern. All 3 of these things are significantly positive. and significantly related to happiness, even though they probably didn't know this game existed a minute ago. So this isn't something that requires a lot of training. This is something that people, at least on average, do right off the bat. And there is this very consistent relationship between these events and their happiness. We have this exponential decay assumption, this gamma forgetting factor that I mentioned. We don't have to, we can just fit it as a regression and show that it looks like an exponential decay. They've only had up to 3 trials, so this is really all the data. We're putting 9 different values in here for each, up to 9 values for each participant. And so what we see is that it's around the last 5 to 10 past events that are influencing how people feel in an environment like this, because you can see that everything since they started the experiment is significantly related to happiness on average. So overall, what this means is that happiness doesn't depend on, at least from minute to minute, happiness doesn't depend on how well you're doing, but depends on whether you're doing better than expected recently. Okay, so if we think about what kinds of...
Can you hear me? Can I stop you?
Yes, of course.
I sort of feel like there's a great deal of information coming across rather quickly here, and I'm just trying to process it. RPE is outcome minus expected value. Is that right?
That's right. That's how we've defined it. You could have other definitions, but that's the one we were using, yes.
And if I understand that what you're showing on the top left here is are the estimated coefficients W1 through W3, I can rewrite this as W1 certain reward plus W3 outcome plus W2 minus W3 expected value.
That's right.
And then that looks a lot like a relative utility function, doesn't it? Because W2 is less positive than W3. So W2 minus W3 is negative, which is the expected value of the gamble.
That's right.
So the higher is the expected value of the gamble, ceteris paribus, the less good you think your outcome is, which sounds a bit like the Mike McBride paper on the expected value of matching pennies against a computer, if you know that one.
Yeah, that's right. Yes. Yeah, you could reformulate it that way and you would get, they're identical mathematically.
Sorry, I'm thinking out loud here. I hope I'm not boring everyone. So that gives you W3 that is about, well, it's about twice as large as W2 minus W3, isn't it, in absolute terms? So half of the value of the reward is dissipated by your expectations. Can I read that way?
I think you could. And I think one way you could think about that is if you if you have advanced warning, then you kind of prevent the extremes in a way, because it kind of, like the negative, having advanced warning that you're going to have a potential negative event reduces the overall affective impact of that negative event, because you have this kind of advanced warning going the opposite direction.
Right. We should bear in mind, though, that people select into these gambles. So if we force them to gamble, I don't know if you do that at any point during your experiment.
We don't in this one, but you're absolutely right. So that's something we have in our current version. Where we
Andrew,
do
which
see the
way
same
are
thing.
you saying that selection bias works? That if you select into gambling, you expect to be very good at it and your expectations are higher, or you select into gambling knowing that it's risky and that tempers your expectation?
I expect you. Actually, I haven't got any clue what I expect. I've got no idea what I expect here. I would have thought gamblers would be better at calculating expected values. So they'd be more precise. What that means for your estimated coefficients, I don't know. But we should bear in mind that this is this is a selected sample. And maybe RPE is more important for people who don't really. No, I don't know. I haven't got any idea. What do you think, Rob? What's your expectation of the
I think
collection? Yeah.
there's a couple of interesting points in there that we don't actually have satisfying answers yet, but we are aware of these issues because one thing is the agency aspect of it. So you do have agency in this task, and the current version of this task in the newest app has trials where you don't have a choice. The gambles, you still have the agency of you get to choose when you start to play the gamble. So in that sense, you aren't completely removed. You don't have your agency completely removed, but you don't have a choice about whether to play or not. And so that's halfway to it doesn't completely address everything, but it's part way to understanding this difference, because I think what you might expect is that the people that are less inclined to take the gambles, they may have a different impact in those trials where they had a choice than in the trials where they didn't have a choice. And that's something that we can look for, but we haven't looked at that yet.
Okay, thanks.
Any other questions? I think this is a good place to think about. This is a result that's extremely robust. And actually, I think one point I should make is that when we think about the difference between the lab experiment and the smartphone experiment, there are a number of differences which make it much less likely there are any important demand effects that influence this particular pattern, because one version is paid with an experimenter in the room part of the time, so it's not anonymous at all, and they're paid quite well actually, and they have, in a sense, a bunch of training in that they play it for an hour. And then this version is unpaid, anonymous, somewhere in the world. They probably didn't read the instructions, for being totally honest with ourselves. And we generate exactly the same pattern. So we really don't see any big differences, despite these huge differences in how these two data sets were collected.
Rob, thank you. Just a point of clarification. So any questions that are clarifying, like the one Andrew just asked, by all means, but the one that are more substantive, we tend to leave them till the end so that you can go through everything. And the aim is to leave lots and lots of time at the end for a proper substantive conversation about the material.
Okay, great. Well, anyway, I think that was a good point. I think the point that you could rewrite the equation in this different way is absolutely correct. And actually, we did a control experiment exactly for that reason, where we don't show them the outcomes all the time, but it still counts. And so at the end, after each block of trials, they find out what their kind of total score is. They get the full update on how they're doing, and we can in that way separately estimate the effects of expectations when you don't get information, because you're told when you're not gonna get information, but those expectations still drive their happiness even though they don't get any information about what actually happens at that moment. And so that gives us some confidence that we're formulating it in the correct way, which also makes more sense in terms of the brain signals, because at the time you make these choices, there are neural signals that are related to the expectations. So it makes sense that that is influencing people's affective state and not just when they find out outcomes. But I think it's a really important thing that we have to think about, because this one experiment doesn't answer all those questions. Okay, so I think one of the things that we want to think about is which people in the world would have a different weighting of these different kinds of events, and in determining their happiness. And an obvious group of people where we might expect a difference is people with a history of depression. There's over 350 million people around the world that suffer from depression. And if we look at the two major clinical symptoms, depressed mood is indicated by subjective report, and a diminished interest or pleasure is indicated by subjective report, those obviously nicely map onto aspects of these tasks. Now, of course, the way those symptoms are evaluated, it's not in relation to something changing on a minute-to-minute timescale, but we can ask whether these concepts also apply in that time frame. And an obvious prediction is that there's a blunting of the impact of prediction errors or rewards on the happiness that people feel during this kind of task. That's what the literature would predict. So we got the same result in the lab, but this is the smartphone data. This is around 1,800 people, 1,200 people here that have low depressive symptoms. And now the question is, if we look at another 500, almost 600 people with high depressive symptoms, do we see the predicted blunting of prediction error influences on moment-to-moment happiness? And we do not find that. If anything, there's a slightly higher emotional reactivity according to this measure. There is no blunting at all, as some of the literature would predict in much more complicated tasks. And this is quite a straightforward, simple task. Now, it's not to say we don't find any changes that would be predicted in relation to depression. We actually, when we look at this W0 set point parameter, we see that it is highly correlated with their depressive symptoms. So when they play the game, they're afterwards asked to do this depression inventory. So they don't know they'll ever be asked. Actually, it's in general, it's not on the same day that they play the game, but we see this very strong correlation. And what that means is the happiness that they're reporting while they play the game is not just related to the local context of the game. It also relates in some way to their overall mood as reflected in their self-reported depressive symptoms. Now, depression is one thing. If we want to understand depression over time or life satisfaction over time, we need to be able to get longitudinal data. And that means we need reliable relationships between these measures and other measures of well-being. And we see some of this consistency already, even though we didn't set out in the first place to get longitudinal data. But we see that when people play the games 2 to 4 weeks apart, there is a strong correlation, not too strong. In some ways, we don't actually want it to be too strong because we expect how people feel during the game should be different from week to week or month to month. But there is a strong correlation in the sample of people that played several weeks apart. And we also get a measure of life satisfaction when they first download the app. And we also see a highly significant relationship between that measure and when they play, the happiness they report during the task. Now, obviously, this is just a starting point. What we'd like to do is get data over many months in people where we can ask them about life satisfaction over that period or depressive symptoms and relate the happiness they're experiencing during these games to these overall measures of well-being. But that's an ongoing project. Okay, so I want to talk in a little more detail about 2 follow-up studies that get at different aspects of how experiences during these games can influence happiness. So one of these is to try to think about why reward prediction errors are related to happiness. Now, we know the brain cares a lot about reward prediction errors, but why is this such an important variable for the brain to represent? The reason is that prediction errors can be used for adaptive behavior. So if you're getting more than you expected, you should choose that thing more often. If you're getting less than expected, you should choose it less often. Now, tangled up in here is this question of reward, because you have the learning that helps you update your value estimates, but you also have a reward that might be dissociable. So it's not clear whether the reward is actually the thing that's driving happiness, or really it's just the learning that is the key part of this relationship. And so this, my former postdoc, Bastian Blaine, was interested in this question, and the way he dissociated reward from learning is to have an environment like this, where you choose which car to bet on. This is a stable environment. In this environment, they don't know this at the start, but they find it out pretty quickly. The yellow car is going to win 80% of the races. And so you should bet on the yellow car more often. But the interesting twist to this task is that the potential rewards for the 2 different cars are randomly assigned on each trial, which means that sometimes it's worth the risk to bet on the slower car, because if that car wins the race, you do get a lot more points. And this is a good example on the screen. This purple car only has a 20% chance of winning, but if you win, you get 60 points. And so you actually should, if you've learned the values and you're integrating this information appropriately, then you should choose it in this situation. And we have a variety of different rewards, which allows us to, they're still going to be correlated, obviously, the reward aspect and learning aspect, but they potentially are dissociable, because you should still choose the slow car if the reward is high enough. He tested not only the stable environment, but also a volatile environment where the probabilities are changing over time, and the participants have to change their learning rates and adjust more quickly when they're in a volatile environment. And they're told this. They aren't told what the probabilities are, but they're told that the probabilities are not going to change. I won't tell you which one is the faster car, but they won't change. And in this one, they will change. And we won't tell you how often, but they will change at some point. And the 2 models that we want to look at are one in which, like our previous model, we have reward prediction errors, rewards minus expected values, and one where we have what we call probability prediction errors, which is just the binary outcome of whether you won or lost, and the probability of that car winning your belief about that car, actually estimated with a learning model. Okay, so there's no information about the actual magnitude of the reward received in this model. So the question is, which of these two models accounts for more? They're both very simple, actually. And we would just want to know, as a starting point, what is accounting for more variance in happiness during this task? And it turns out in the stable environment, you can see on the y-axis is the R² for the probability prediction error model, x-axis the same number of parameters, reward prediction error model, and on in more subjects, the probability prediction error model is accounting for more variance in happiness. And we see the same thing as well in the volatile environment. Around 2/3 of the participants are better explained by this model, even though they have a similar level of complexity. Now, that wasn't our final model. We also, the winning model also included the probability of your car winning, that P of J in the middle of the equation there. And you can see the average trajectory of happiness during the task in the stable environment on the left and the volatile environment on the right. You can see these dips after every 20 trials in the volatile environment, kind of what you'd expect. Right after the probabilities change, you get less rewards, and it takes a little while to recover. So you can see that learning happening where they adjust their beliefs. And so this is basically the equivalent of our earlier model, just without reward, because it's expectations and prediction errors related to those expectations that determine happiness over time. So overall, what we're saying across these two different environments is that when we can dissociate the influence of reward from learning is what dominates changes in happiness over time. And actually knowing what the exact reward magnitude is doesn't actually allow us to predict happiness any better. The final study I'm going to show you relates to intrinsic rewards. So one thing we're trying to do is understand variation.
Sorry, Rob,
Yes.
just your conclusions from this are kind of an adaptation story, aren't they? That you learn that it's going to be volatile and you recover. And, people do adapt to a lot of events and then kind of go back to their normal levels of happiness.
So I think that's true. I think partly here, this dip in happiness, which also relates to lower rewards as you adjust, and this recovery coincides to improvement in your choices because you adjust your behavior accordingly. And so whether they would have adapted their happiness even if they hadn't improved their performance, well, I suspect they wouldn't. And I think it probably it's hard to distinguish whether they would have gone back to their baseline if they had continued to do poorly, because on average the people do quite well in adapting. It just takes them half a dozen trials to kind of adjust. So we can't, maybe it's hard to distinguish those two things in this kind of context. But absolutely, I mean, I think adaptation is key to this, and I think that's partly the adaptive role of happiness in these kinds of environments. Presumably relates to their ability to encourage adaptive behavior, which is maybe a little bit different than just having adaptation in your in terms of returning to a set point for your happiness.
Yeah, no, I agree with you, but I was linking adaptation to the learning part of this model, right? That, you learn that if you fail, it's not permanently over, and you adapt more to volatility than you would otherwise. That was just my thought.
Yes. So, okay, I see. That makes more sense. Sorry, I misunderstood in the first place. Yeah, one thing that's interesting here, part of the reason we were interested in setting up these two different contexts is that it's well known that people change their beliefs much more quickly in the volatile environment. And we didn't find that this meant that their emotions, for example, were more volatile, or that they changed their happiness more rapidly. And so what exactly that means for the adaptive role of happiness, we haven't quite figured out, but that was a surprise for us, that the volatility of happiness is kind of a more stable trait across these different contexts. So I want to finish with one last study related to intrinsic reward and the differences across individuals. If we think about the things we value in life, a lot of them aren't at least completely, obviously, extrinsically rewarding. So when we donate our time, when we do altruistic acts, when we do something that's difficult, like climbing a mountain or some athletic pursuit, when we play a musical instrument. So there is some aspect of these different kinds of rewards that we might think of as being more extrinsically rewarding compared to extrinsically rewarding. And so my PhD student, Benjamin Chu, and my postdoc I mentioned, Bastian Blaine, were interested in whether we could set up an environment in which there might be some more intrinsically rewarding aspect of the task. And this is what they came up with. So you make a choice about which arm of this T maze to go down, and then you get points for that. And that's extrinsically rewarding. You get paid based on that. But the thing you have to do to get to that is to navigate through this maze. And if you hit one of these barriers, you just have to navigate around it. So the penalty is just a couple hundred milliseconds of your time. And the difficulty is staircased so that everyone is forced to be at around 70% navigating through without hitting any barriers. Let's see another example. Okay, yeah. So in this case, they almost make it around all the barriers, but they hit that last one. And you can imagine this is something where some people find this intrinsically rewarding to navigate through without hitting a barrier, and other people just don't care. They don't get paid for it. And so the main thing they care about is the points they get. And we find evidence of that on average that people care about both of these things. In blue is the rewarding outcome. So the happiness they report is higher when they get a large versus a small number of points. And in orange is perfect, what we call perfect versus imperfect performance. All that is not hitting a barrier versus hitting at least one barrier. And we can see on average, both of these things are influencing happiness. What's interesting is there's actually a huge amount of variability in how much each of these things influence happiness. Obviously, there's a lot of people that care about both of these things, at least according to this measure of happiness. But there are a number of people that are along one axis or the other. They only seem to have their happiness modulated by one aspect of the task, even though the level of performance is actually very similar across individuals by design. Now, we were actually scanning people. So these are the averages of a computational model that includes both these parameters. So on average, there's this main effect where both of these things matter for happiness during this task. We were scanning people in the MRI machine while we did this, and what we found is that both rewards and what we could think of as skilled performance, so not hitting a barrier versus hitting a barrier, both of these things modulated neural activity in the medial prefrontal cortex. So this is just in the middle, in the front of the brain. This is an area that's been closely linked to extrinsic reward, and we find an overlapping area of the brain is responding to these intrinsic rewards. Now, I think the thing that's most interesting about the study is that the degree to which each of these things influences happiness on the x-axis is predictive of how much they influence the brain. So in this brain area, we can see if you don't care about navigating this maze, you also don't have any brain activity that's modulated by navigating this maze, even though the performance is set to be the same because we've titrated the difficulty until they're all at roughly the same level of performance. And so the performance is basically matched in these cases, but the amount that these extrinsic and intrinsic rewards influence happiness and brain activity seems to vary quite a lot with this fixed relationship. So I think this relates a little bit to the idea that was proposed over 100 years ago of a hedonometer, an ideally perfect instrument, a psychophysical machine continually registering the height of pleasure experienced by an individual. But I think actually there's something that's not quite right about this idea, and that you don't actually know from just knowing how happy someone is at a given moment what caused that. And so what we've shown is that even things are what we could think of as more intrinsically rewarding are something that we could, as long as we can measure them repeatedly, we can measure their impact on happiness and extract this kind of computational parameter that relates to how much different kinds of experiences influence a person's momentary happiness. So just to summarize, I've shown that happiness depends not on how well you're doing, at least minute-to-minute happiness depends not on how well you're doing, but whether you're doing better than expected recently. This is a result we've replicated in literally thousands and thousands of people. And it also seems to relate not only to your expectations, but also things you find intrinsically rewarding, something about your values. I've shown that the dynamics of happiness can be measured using smartphone games like those in our app, the Happiness Project. I think that's a promising tool for relating happiness in these different contexts to happiness in real life. That's something we're working on. We're asking people about their happiness as they go about their daily life and measuring things like depression, life satisfaction over several weeks, in some cases several months, to try to predict those changes in advance. we find in these last experiments that happiness can depend more on learning than on reward in uncertain environments, which, I'd say our current world is pretty uncertain. So maybe this is relevant now. And finally, across multiple studies, we found that dopamine-related neural activity reflects the impact of both extrinsic and intrinsic rewards on happiness. So the happiness we feel from moment to moment depends on our expectations and our values, but it mostly reflects recent news. And so in this way, it seems to me that it's less like a goal and more like a tool that can be used in making better decisions. So thank you for your attention.